All right, so looking at this first example here, basically simplifying rational expressions or just simplifying complicated fractions is basically what it kind of all boils down to. So the same rules that we applied to simplifying fractions before, we will still apply. So looking at this first example here, I'm looking at 12 divided by 6. So 12 divided by 6, I can divide a 2 out of both of those. So if I'm simplifying the fraction, that's really 2 over 1. So I end up with a 2 on top of my fraction. And then I look at the variables, and if you remember our simplifying variables rules for the exponents, we're really just subtracting. This x squared on top is really just like 2x's on top. X to the third down on bottom is like 3x's on bottom. So if I have 3 and I take away 2, I'm left with a single x down on bottom. And then looking at the y's, I have 5 y's on top and a single y on bottom. So 5 y's, take away the one that's on bottom, and I'm left with 4 y's on top. So 2y to the fourth over x is my answer there. So I'll go ahead and pause it, or you can go ahead and pause the video and do the try this and start it up when you're ready. Okay, so if I'm reducing my fraction, 15 and 10 are both divisible by 5. So 15 divided by 5 is 3. 10 divided by 5 is 2. So I have 3 over 2. I have a single a on top and a single a on bottom. Those cancel out nicely. 6 b's on top. Take away the 3 b's that are on bottom. Leave me with 3 b's on top. So I have 3b to the third over 2. Okay, so this is kind of the simplest version of simplifying rationals. Let's look at some more complicated examples. But before we do that, I want to review our factoring rules, because in order to really know what we're looking at so that we can cancel stuff on top and bottom, we need to be able to factor the complicated expressions down into their simpler parts so that we can kind of look at what we're really looking at. So let's look at our factoring rules. Okay, so our factoring rules, remember, the first thing I should always try is try a GCF. Okay, I should always look to see if there's something in common that I can divide out of all of the terms, because that will be the quickest and easiest way to simplify. And then second, from there, all I do is check the number of terms, and that should tell me what to do, right? So if I have 4 terms, that's when I'll group. If I have 3 terms, that's when I do my AC or the shortcut if you are able to. And then if I have 2 terms, you can either put the 0 in and do AC, make it 3 terms if you want to, or if you remember, you can do the difference of squares. Okay? So we always try a GCF first, and then it's just based on the number of terms. If I have 4 terms, I group. 3 terms, AC method. 2 terms, difference of squares. Okay, so let's look at an example here. So example 2 here, you can see that I have some stuff on top that some addition and subtraction on top, or just addition on top in this problem particularly. And your first temptation, and I don't want you to write this, but your first temptation may be to say, okay, well, I can cancel 5a and 5a, and the answer is 10. But I want to take a pause there and ask you. So say I had, just a simplified version, say I had 2 plus 3 over 2. So if I apply the same rule here, and we know that 2 plus 3 is 5, so this is really 5 over 2, right? I don't know why I wrote 5. 5 over 2. Okay, but if we apply the same rule that we did up here and say, okay, well, I can cancel those, then I should be able to cancel 2 and 2 and say the answer is 3. But I know that obviously 3 is not the same as 5 over 2. So the reason I show you this, the reason I tell you that is just to say you are never, ever, ever allowed to cancel stuff if it's involved in addition or subtraction. So let me get rid of all this stuff. So since this 5a is involved in an addition problem up here, I am not allowed to cancel it. So just a reminder, if it's ever involved in addition or subtraction, you can't take part of it. You either have to take all of it or none of it. So since I don't have the plus 10 down on bottom, I can't take all of this 5a plus 10. What I can do, and this is when our steps come in over here, is I can factor. So step one is always going to be factor the top and factor the bottom. Okay? So if I factor the top and factor the bottom, then I'll be able to know what I'm really looking at, and it'll break it up into separate pieces that then I can try to cancel. So on top, remember my step one for factoring is always try a GCF. So on top, hopefully you notice that both of these are divisible by 2. So if I take, both divisible by 5. So if I take a 5 out, 5a divided by 5 is a, and 10 divided by 5 is plus 2. Okay, so I replace that top part. 5. We can see that the bottom 5a does not need to be factored. So my new factored form is 5a plus 2, and on bottom 5a. Okay, so at this point we need to come over here, and I actually need to amend the steps because I forgot to change it, but why'd that disappear? So step one is factor. Step two would be state restrictions, okay? And at this point, we kind of need to pause because you're probably asking, well, what are restrictions? We've never really looked at something like that before. If you remember, in math, we are never allowed to divide by 0. So I want to make sure and avoid that here. So the way that we do that, I just come over here, and that's where I'm going to do my restrictions. And I say whatever is on bottom. So after you've factored it, whatever is on bottom, in this case, it's the 5a. So 5a. I say whatever's on bottom cannot be equal to, so that's a not equal to sign, 0. So 5a is not allowed to be 0. So this is really similar to just finding zeros, except now we're finding not zeros, okay? So I want to know what the bottom is not. The bottom is not allowed to be 0. So I need to know what a is not allowed to be. So if I divide by 5 and just solve for a, then I end up with a cannot be 0. So there is my restriction. Now I need to find the simplified answer. So looking back over here, on top, this is 5 times the parentheses. This is 5 times a. So since both of those 5s are involved in multiplication and not involved in addition or subtraction, I can go ahead and cancel my 5s. You may be tempted to say, well, Mr. Craw, I can cancel out my a's. But remember, since this a right here is involved in addition, a plus 2, I cannot simplify these a's. I can't take them out. Okay? So that makes my final answer, a plus 2 over a. And we say when, this is when our restrictions come in, a is not allowed to be 0. Okay, so it's a plus 2 over a when a is not allowed to be 0. So this is my answer, my simplified form, and here's my restriction. So this restriction is just saying at no point in time, if you're graphing, if you're looking at this, I can't make a 0. Okay? All right, let's look at one more example together to kind of pull it all together here. Okay, so I want to simplify this and state any restriction. So I start out by factoring. So on top, I look up at the top and I see that both of these are, I try a GCF, both of these are divisible by 7. So if I take a 7 out of the top, 7s divided by 7 is s, negative 28 divided by 7 is negative 4. So 7 parentheses s minus 4. That's what this top part becomes in its factored form. And on bottom, I try a GCF. Nothing comes out of all three of them. And then I have 1, 2, 3 terms. I remember that if there's nothing in front of s squared, I can do my shortcut. So I'm just finding what multiplies to negative 28s squared. That would add to 3. Ooh, sorry, bless me. So things that multiply to negative 28 that would add to positive 3 would be negative 4 and 7. And remember, those go straight into my parentheses. So down on bottom, my factored form is going to be, S, not X, sorry, is going to be S minus 4 and S plus 7. Okay, so remember at this point I need to kind of find my restrictions. So I'm going to come over here to some free space I have and find restrictions. So remember, whatever's on bottom, so in this case, S minus 4, S plus 7, cannot be 0. So just like when we were finding zeros, remember, in order for this whole thing to be 0, either this piece could be 0, this piece could be 0. Well, now I'm kind of doing the opposite of that. So in order for none of this to be 0, this cannot be 0 and this cannot be 0. So I set up my two equations. S minus 4 cannot be 0, and S plus 7 cannot be 0. So it's just like finding zeros, except now you're doing not equal to instead of is equal to. So add 4 to both sides, and I get S is not allowed to be 4. Subtract 7 from both sides, and S is not allowed to be negative 7. So I'm not allowed to use, I would not be allowed to use these two S values if I was graphing or using some other kind of solving technique or anything like that. So that being said, now I need to simplify on example 3. So I look for stuff that is common on top and bottom. Now at first glance I see 7 on top and bottom, but remember, since this is involved in addition, S plus 7, and this top part doesn't have the S with it, I can't take that 7. But I do see S minus 4 and S minus 4. And yes, this is subtraction, but the exact same piece is the big piece is exactly the same. So since S minus 4 and S minus 4 are exactly the same, I can take that whole piece out. Again, I can't take the 7s because this one's involved in addition. So that makes my final answer 7 over S plus 7. Don't forget your restrictions when S is not equal to 4 or negative 7. So there's my final answer. 7 over S plus 7 when S is not equal to 4 or negative 7. So remember, step 1, factor top and bottom. Step 2, find your restrictions. And then step 3, simplify and finish your problem out. Okay, so go ahead and pause the video. You can do the try this there. And then you can go ahead and start the video up when you're ready. Okay, so on top, I'm looking at 1, 2, 3 terms. So I'm doing AC, or the shortcut. So I want factors that multiply to negative 8x squared that would add to negative 2. So that would be positive 2 and negative 4. So the top factors into x plus 2 for the positive 2, x minus 4 for the negative 4. So there's the top factored. Now the bottom, let me see if I can move this. No, I'm not going to be able to. That's okay. So on bottom, I have a couple factoring things that I need to do. So I take the bottom, and first you can see that they're both divisible by 2. So when I see that they're both divisible by 2, I can take the 2 out, and then I'm left with x squared minus 4. And then if you also realize this is a difference of squares in here, right? I take a GCF and then I look for the number of terms. There's only 2 terms. So the square root of x squared, the 2 things that I would have to multiply to get x squared would be x and x. 2 things that I would have to multiply to get negative 4 would be positive 2 and negative 2. So this 2 comes down. The 2 things that I would have to multiply to get x squared would be x and x. 2 things I would have to multiply to get negative 4 are plus 2 and minus 2. So now that's completely factored. So I can go ahead and put that in over here. So I have 2, x plus 2, and x minus 2. And I know that may seem a little tricky to you. You haven't seen difference of squares in a while. But just keep practicing. You'll get it. Okay, so I take out a GCF and then I look for the difference of squares. Alright, so now that I've done that, I'm going to come all the way over to the side and do my restrictions. And remember, whatever is on bottom, so 2, x plus 2, x minus 2, cannot be 0, so it's not equal to 0. This first piece out here, 2, is never going to be 0, so I'm not worried about it. But x plus 2 is not allowed to be 0, and x minus 2 is not allowed to be 0. So solve both of those. Subtract 2 from both sides, x is not negative 2. Add 2 to both sides, x is not positive 2. So there are my restrictions. Now I can go ahead and simplify and finish out my problem. So again, I see a whole piece of x plus 2 on, that's minus, so a whole piece of x plus 2 on top and bottom. So I can go ahead and take those out. So x plus 2 and x plus 2 is gone. And then I am left with x minus 4 over 2 and x minus 2. So I have the x minus 4 left on top, the 2 and the x minus 2 left on bottom. And I'm going to say when x is not equal to, don't forget your restrictions, negative 2 and positive 2. So here is my final answer. Okay, so we're going to go ahead and skip example 3. So I want you to flip it over to the second page. And we are only going to do the try these A on the back. So one more for you to practice before you are done with notes. So go ahead and skip B, just do try this A. So go ahead and pause the video, work on it, and then you can play the video when you're ready for me. Alright, so I start out by factoring. So on top, x plus 2, there's no GCF. There's nothing really I can do with that. So the x plus 2 is going to stay up on top. Then on bottom, I try a GCF, nothing comes out, and I have 1, 2, 3 terms. So I'm doing the shortcut, so I need what multiplies to 6x squared, that adds to 5, that would be 2 and 3. So on bottom, I have x plus 2 for the positive 2, and x plus 3 for the positive 3. So now that I've factored, I'm going to come over here and find my restrictions. Remember the bottom, so x plus 2 and x plus 3 cannot be 0. So in order for none of this to be 0, x plus 2 cannot be 0, and x plus 3 cannot be 0. So subtract 2 from both sides, x is not negative 2. Subtract 3 from both sides, x is not negative 3. So there are my restrictions. Now I can go ahead and simplify and finish it off. So I see the whole piece of x plus 2 on top and bottom. So I can take that whole piece of x plus 2 out. And now I'm ready to write my final answer. So if I take everything off the top, don't just put nothing there. Remember, if I divide everything out of something, I'm just left with 1. And then I'm left with x plus 3 down on bottom. And then don't forget your restrictions. When x is not negative 2 or negative 3. And there is my final answer. Okay, so you are all done with notes and you are ready to move on to the partner activity. Go ahead.